At 07:42 a.m., 12th of March 1941, fog still clung to the shoreline of the construction yards at Quonset Point Naval Air Station, Rhode Island. On a muddy concrete pad next to the buzzing drills and rivet guns, Otto Brandenberger, assistant engineer for the contractor George A. Fuller Company, straightened his goggles and surveyed the first curved steel rib arriving off the truck. The order had come just 60 days ago: deliver a prefabricated hut that could be bolted together by 10 men in a day. The British Army's Nissen Hut had already proven its portability and speed in 2 wars. Now the US Navy demanded something faster, lighter, mass-shippable. A knock on the rib jarred Brandenberger from his thoughts. A rivet popped loose. If the hut failed here under these conditions, thousands of soldiers overseas would pay the cost. The blueprint lay open beside him. 16 gag 36-foot T-rib section, A1. And as the workers shouted over metal on metal, Brandenberger knew the world was about to see a structure that could win or lose, a war of logistics. Early March 1941, Quonset Point, Rhode Island, US Navy's Advanced Base Depot. Brandenberger had joined the Fuller Company design shop only 6 months earlier. Rising through the ranks from conventional steel frame skyscrapers via his firm's Chicago and New York legacy, he now stood in this salt-sprayed yard, surrounded by dozens of long crates stamped Hut Kit USN Yards B, G, and D. The US Navy's Bureau of Yards and Docks had specified the requirement: a semi-cylindrical, galvanized steel shelter that could be shipped in pieces, erected by unskilled labor and easily reused at remote outposts. He flipped through the spec: arch-shaped, minimal interior posts, steel ribs every 4 feet, corrugated steel skin. He looked across the yard, the workers unloading crates, a group of Navy Seabees shadowing the contractor's men. For them, this was war business, but for him, it was the first true test of his engineering career. The smell of cutting oil and galvanized steel filled the damp air. He thought of Britain. Earlier in the war, the British Army had used the Nissen Hut, invented in 1916 by Peter Norman Nissen, which could be packed on a truck and erected in 4 hours. Now the Americans wanted better: bigger spans, faster erection, shipping economy. Brandenberger's goal: deliver a prototype kit within 60 days. He briefed his team. Ribs first, shell then floor. We must hit shipping weight under 4 tons. In the first crate he found a mismarked gusset plate, a small flaw, but one that could cascade under field use. He flagged it. The hush fell. They were racing. The first ribs were bolted to the pad as twilight returned. Brandenberger noted the first crate was tagged QA Hold. The hut that would become ubiquitous was still experimental and could either lift or leak the war. Mid-March 1941, Quonset Point Assembly Pad. Within a week of the first parts arriving, the crew attempted the first full kit, erection. Brandenberger watched as 10 men in leather gloves lifted the first curved half-ribber and slid it into the stamped rail. The rattle of bolts, the hiss of galvanized steel, the crunch of gravel under boots. This was not an office drawing board. On the second rib, 1 bolt stripped. A man muttered under his breath. The floor plan called for a 16-foot width, 36-foot length, mirroring the British Nissen's compact size, but the US version would later scale to 20 by 48 feet. Brandenberger crouched, wiped oil from his goggles, and felt an internal pressure. This kit must be ready before shipping to Iceland, the Aleutians, or the Pacific. He saw the wrench slip, the bolt torque overrun. The men paused. The engineer frowned. In the British Nissen design, the simplicity had meant 6 men could erect a unit in 4 hours. Here, even the prototype was slipping beyond a day. He called the crew together. "Let's take 5 minutes. Check rivets and gussets. Identify the weak point. They pulled the shell half open and found the insulation block shifted during lifting. A subtle detail overlooked in the British version, which lacked insulation entirely. He scribbled notes in his pad. Rib curvature interfering with floor joist. The tension mounted. The men restarted, the last rivet hammered at dusk. Brandenberger glanced at his watch. 17:59. They finished. Just under 10 hours. Not bad, but not the 4-hour target. He let himself rail a moment. We're behind. He knew this prototype must ship by the end of April. The US design was proving more complex than expected. The British benchmark loomed. Late March 1941. Quonset Point Design Workshop and Steel Plant Coordination. In the design office, Brandenberger met with the steel vendor representatives from Strand Steel Corporation, a subsidiary of Great Lakes Steel Corporation. The vendor insisted that the steel sheet corrugation must run parallel to the radius of the arch for water shedding. Brandenberger paused. This added cost. He asked for weight per crate reduction. The vendor offered a new 16-gauge steel instead of 14. He approved. Meanwhile, logistics folks tracked crate shipments. Each hut kit had to be broken into 10 crates to fit on standard railway flat car and ship's hold. Weeks earlier, the British Nissen had standard trucks. Here, America wanted mass load for the Pacific campaign. A memo from Budox read, "Prefabricated hut must be fully erectable by 10 men within 24 hours with only hand tools." Brandenberger placed the memo on his desk, a crisp navy letterhead. The challenge felt immense. He paced the workshop. Rivet guns, wooden spacers, yellow steel ribs, stacks of masonite boards for interior lining, unlike many original British huts. He realized the extra floor height, insulation layer, interior wood lining added weight and complexity. The British design had little of this. He made a silent vow. We'll match Britain's speed and beat it. Shipping instructions arrived. The first 300 kits were bound for Newfoundland for base construction. Deadline 15th May 1941. The production ramp was scheduled. Any delay would ripple across the Atlantic supply route. Early April 1941. Gravel pad beside Quonset Point. Dawn. Sunlight slanted through steel skeletons. Brandenberger walked through the yard as the second prototype kit approached assembly. The crew was larger now, 12 men. The improved version included a 4-foot vertical knee wall at each side, an American innovation to increase useful interior volume. This deviated from the British full-arch slope design. The knee wall required extra rib fabrication, extra welds, extra time. A rigger slipped on the damp steel and twisted his ankle. The assembly stopped for 5 minutes. Brandenberger stepped in, handed the man water, checked the injury. The stakes were real. As they resumed lifting the curved panels, the steel frame groaned, rivets popping. He crouched, hearing the sound mix of metal and fatigue. Engine idling, seagulls overhead, the hisses of compressed air tools. This time the crew completed in 8 hours, still double the British benchmark. He pinched his lips. Off to one side, he heard a message via radio from the base. Request update on hut shipment to Greenland. Priority 1. He noted, the cold climate will test insulation. The British huts lack this feature. He swung his clipboard. Document the floor joist offset. Confirm crate labels. Double-check packing list includes insulation and floor panel hardware. A loaded flat car left for Rhode Island port. The crates stamped Hut Kit USN 1636 redesign. The redesign phase was underway, but delays and human cost were creeping in. Mid-April 1941, Seabees training camp, Davisville, Rhode Island. At the adjacent training camp, A young Navy Seabee mechanic, Jim Red Calhoun, scratched his helmet as he and his team unpacked their first Quonset kit at dawn. They were sent to Greenland the next week. Calhoun felt cold even in Rhode Island. The corrugated steel panels were hard, unforgiving. He listened to the drill commander. "You've got 1 day, hands-free, to erect the hut kit. This is standard issue now." The crew hoisted the ribs. Calhoun hammered the final corner and felt metal flex under his glove. He thought of his friend overseas in the Aleutians who still lived in tents. This hut, his first, might change that. After 9 hours and 45 minutes, the structure stood. A gleaming semicircle, plywood ends, doors, 2 windows. Calhoun wiped blood from a cut on his knuckle, a stray rivet edge. He looked inside. The floor joists bowed slightly under his boots. He radioed the base. Frame completed, but joist clearance low on the west side. Back at headquarters, Brandenberger received the note and immediately penciled a design tweak. Increase joist, rise by 1.5 inches. The British Nissen crews in WWII and WWII routinely built these huts in less time, so the pressure was fierce. That night, Calhoun stared at the sheets of steel roof. He felt a surge of pride. He helped erect the building. But he also sensed unease. The interior sides sloped steeply, limiting usable space. He turned to his friend in the tent and said, "At least in a hut like this we won't freeze, but we might bump our heads." Field crews were using the design, discovering real-world flaws. The race was now in feedback loops. Late April 1941, Quonset Point Design Workshop. Back in Rhode Island, Brandenberger stood over the design board, red-penned markups, cross-sections of rib spacing, insulation layers, floor joist bearing. Production had begun in earnest. April shipments going to Newfoundland, Iceland, Greenland. He reviewed a memo. 8,200 huts shipped by end of 1941 expected. He highlighted the manufacturing log. The original 16-foot by 36-foot model used 4 tons of steel, but the new 20-foot by 48-foot version used 3.5 tons due to lighter gauge materials and improved framing. He recognized the British Nissen design had fewer moving parts, simpler build, but the Americans demanded larger size, more comfort, insulation, which meant more time and complexity. He called his lead engineer. "We must simplify the T-rib. The longer build time costs lives overseas." They drafted the Quonset redesign with vertical knee walls, lighter framing. Meanwhile, on the shop floor, welders and mechanics felt the push. Quotas rising, delivery schedules tightening, the smell of welding gas, the heat of steel, the clink of loading crates into ships, all part of the war machine. At dusk, the yard ceased, but Brandenberger remained, hand-tallying crates a final time. He thought, "Britain did it faster. We must close the gap." The redesign was ready, but the schedule remained tight and expectations even tighter. May 1941, convoy unloading dock, Reykjavik, Iceland. In the frigid air of Iceland, Calhoun's Seabee team stood by the shipped kit crates. Snow drifted. The crates were slick. The assembly site yielded wind gusts that slapped steel panels like knives. The crew opened the first crate and hauled out ribs, floors, insulation, bolts, windows. Calhoun's breath rose in clouds. The ground shook as a supply truck rumbled past. The British Nissen huts in these cold outposts often lacked insulation, and the interior often froze. Calhoun placed the first floor panel, heard a groan. The joists had sagged again under the cold. He radioed, "Floor clearance low, shift needed." Lieutenant Ross responded, "Do your best. We'll live in 48 hours." The team scrambled, lifting and shimming. At 22:30 the structure stood. Inside, Calhoun flipped a switch to the oil heater. Warm air circulated, the steel walls rattled faintly. He exhaled. He felt the difference. This hut felt more habitable than the old canvas tents, but he also knew it took more effort. He glanced at the curved walls. Full arch gives less vertical wall space than squared versions. He muttered, "We still lose usable room." Meanwhile, a convoy alarm blared. The crew scrambled inside for cover. The hut shuddered under the echoing blast of a nearby training bomb. Calhoun felt the structure flex but hold. He pinned the steel panel. We made it. The hut worked in the field, but logistic, dimensional, and human costs remained. Summer 1941, Quonset Point manufacturing shed. Production lines churned. Brandenberger walked through the steel fabrication bays, press lines shaping ribs, flat-pack corrugated panels stacked, crate labels moving. A foreman called out, "Team 3 just hit 12 huts per day, up from 8 last week." Brandenberger nodded. He reviewed shipping manifests, to Britain, to Alaska, to the Aleutians. He opened a report. British Nissen Hut assembly time averaged 4 to 6 hours. US Quonset today averages 7 to 9 hours. He frowned. The American ambitions for more interior space and insulation were costing time and labor. He addressed his team. "We must redesign again, lighten the ribs, simplify the diagrams, shrink parts count." They sketched the next version, the strand steel framing system replacing T-rib with welded channel I-beams, roof panels that could be shipped flat, and removal of knee wall in the next generation to save parts and time. But he also sensed fatigue. His mechanics had cut fingers, riveters had muffled hearing, logbooks showed 2 men off with heat exhaustion that week in shiphold packaging. The human cost weighed. He paused by a crate stamped Hut Kit 20x48 to Pacific. He thought, soldiers will live in these. They'll fight from these. If we delay, the enemy doesn't wait. The next generation was in motion, but inertia had built, and the British benchmark still haunted. 7th December 1941, Honolulu Harbor, territory of Hawaii. At dawn, seismic shockwaves, still rolling from the attack on Pearl Harbor. Brandenberger received word at Quonset Point before breakfast. The United States was now at war. A telegram. Production priority increased. 150 huts per day target. He sank into the chair, inserted a draft emergency order, scrap all non-essential features, reduce assembly to 2 shifts, deliver worldwide. He thought back to his earlier prototype, the slow build. A file on his desk. British Nissen Hut made 100,000 units WWII. Their wartime assembly, record 1 hour 27 minutes, for a 24 by 60 foot version. He slammed his fist on the desk. The race was no longer academic. He ordered the full-scale switch to the strand steel system. The first freight of the new strand steel Quonset 20 by 48 model left the yard that afternoon. The design already cut parts count by 35%. Meanwhile, the British in North Africa and the United Kingdom were using Nissen Huts en masse for forward airfields, medical stations, and supply dumps, often assembled in hours, moved in days. The Americans now needed the same tempo. Brandenberger typed a note. Every hour saved assembly time equals lives in theater. As night fell, he mapped crate shipments across the Pacific, Alaska, Midway, Guadalcanal. The hut he designed was about to be deployed where men would die without shelter. The war had arrived. The hut must move faster than enemy bullets. Mid-1942, Guadalcanal Forward Airstrip Construction Site, Solomon Islands. In the humid dawn, Calhoun's Seabees team unloaded crates labelled Hut Kit 20x48 strand steel series on a stripped coral base. Tropical heat pressed off the sea. Mosquitoes droned. Rivets sizzled in the air. They opened the crates. Ribs lighter than his first Georgia climate ones, panels with factory-drilled holes, insulation blankets labelled Kimsel. He placed the first floor panel. He counted rivets, fewer than before. They hoisted the ribs. 8 men. 2 hours later, the arch stood. The side walls curved, but a gap at the end showed daylight. He climbed inside, heard the sea breeze rush. He called, "Seal the ridge cap." A senior NCO looked at his time. 2 hours, 56 minutes, the fastest yet. He grinned. Inside that half-arch, the men stripped off gear and cooled down. The hut took on its function, an operations room by evening, and the difference from earlier versions was real. Yet Calhoun glanced out at the sloped walls. Equipment longer than 4 feet wouldn't fit flush. The base design still stuck with a semi-cylindrical shape over the full arch. He thought, Britain's Nissen had a full slope, but narrower width, fewer wasted inches. That night a bomb shook the perimeter. Calhoun sprinted inside his hut as alarms blared. The steel moaned, but held. He panted. He touched the floor joist, cold like the sea. This hut saved his team's lives. The Quonset was now proven in combat theatre, but its more complex genesis still lagged the leaner British legacy. Late 1942, Quonset Point, Rhode Island and shipyard dock, night. Brandenberger returned to the design shop, drained from months of overtime. The yard lit by flood lamps, crates stacked 25 high, forklifts humming. A message came in. Production at 150 units per day, achieved last month. He exhaled. Yet he knew the bitter truth. The British Nissen Hut, available since WWII, had decades of deployment and simplicity. The Americans had aimed bigger, 20 by 48 versus Britain's typical 16 to 24 by 36 to 48 spans. He reviewed comparative metrics, manufacturing cost per kit, shipping volume reduction, assembly hours. The originals still held advantages in speed and simplicity. He tapped his notes. Complexity added. Knee walls, insulation, larger span equals higher labour, more crates, longer shipments. He flagged a log. 8% crates arrived damaged in Pacific transit due to long distances. He quietly regretted the trade-offs. A colleague asked, with Britain you'd build in hours, we still build in days. Why? The answer hovered. Because our scope was greater. More interior space, better insulation, global deployability. He stared at the blueprint of the next Elephant Hut, 40 by 100 feet, intended for warehouse use. Many would latch on to US mass volume, but his heart knew the British design still led in rapid deployment. The US design won the war of volume, but the British design retained the edge in speed and simplicity. August 1945, Okinawa Base of Operations. Autumn war-weary dawn. The Pacific War was nearing its end. Calhoun's Seabees unit prepared to dismantle their double-wide Quonset Hut operations room. The site was battered. Coral dust, war scorch, machine gun fire. The curved steel roof still gleamed, though dented. He climbed inside and ran a hand down the interior masonite wall, warm from the Pacific sun. He thought of the British forward field hospitals hundreds of miles away. Their Nissen huts had served continuously, stripped of adornment, rapidly erected. Here his Quonset had provided comfort, but at cost. Extra crates, longer assembly, logistic tail. He packed a crate label. Hut kit 20x48 strand steel 1942 USN. He radioed the deassign message, building ready for shipping to Alaska relocation camp. He paused at the threshold and looked back. The hut had saved lives, shipped across an ocean, assembled under fire. He placed his helmet on the floor and walked away into the palette of grey dawn. The war ended. The hut remained as testament, but its trajectory was not as simple as speed alone. Post-war America, early 1950s, a college campus turned veteran housing village. In the Midwest, the surplus Quonset huts were sold to public use. One such 20 by 48 model was repurposed into married student housing. An archival quote printed in a government report from 1947 read, "The Quonset hut is the first mass-produced movable building of steel. More units have been produced of this type than any other military structure." Brandenberger, now older, visited the campus in spring. He walked down the row of semi-cylindrical buildings, children playing in the grass, vines climbing the steel ribs. He remembered the factory noise, the stress of deadlines, the rivet gun echo in Rhode Island. He thought of the British Nissen huts, still in use in Britain, converted into homes or storage. He realized the truth. The US Quonset hut achieved its mission, mass deployable, global, but could not match the minimalist speed of Britain's earlier Nissen design for rapid field erection. The British model had fewer bells, fewer enhancements, and therefore reached deployment faster. The US model offered more comfort, more space, but at the cost of time and complexity. He looked at the off-mark gravel where one hut ended. The curved wall still bore weather scars. He sat on a crate used as a bench and wrote in his margin, "Simplicity often beats size when speed is the metric." He closed his notebook. The wind rustled across the corrugated steel. A final archived note appeared. By the end of 1941, approximately 8,200 Quonset huts had been manufactured and installed both in the United States and abroad. As the camera pulled back, the row of huts stretched into the horizon, relics of a fast-moving war where design, human hands, and logistics collided. The British Nissen Hut, pioneered by Lieutenant Colonel Peter Norman Nissen in 1916, embodied simplicity, portability, and speed, at least 100,000 built in WWII. The US Quonset Hut, initiated 1941 at Quonset Point and developed by George A. Fuller's team under Brandenberger, produced roughly 150,000 to 170,000 units in WWII. It delivered global utility, but its ambition added cost in time relative to its British predecessor. In this human-driven story, engineers, mechanics, and Seabees alike wrestled not just with steel and bolts, but with the zero-sum equation of design speed survival.